second lecture on selecting best regressor model. Suppose you have a problem with a large number of regressors and one response variable. Having large number of regressors, you may wonder whether some of them are irrelevant for the response variable, and whether those irrelevant regressor variables can be removed from the model without affecting the model predictive power. Okay. So, by the best regression model in multiple linear regression setup, we mean a model that can explain the variability in y, and at the same time it includes as few regressors as possible, because more regressors in a model, if you have more regressors in the model, then greater the cost of collecting the data, and also the cost for the maintenance increases. Well, so the known algorithms for selecting the best regression model, they are basically classified into two classes. One is called all possible regression approach, and the other one is called sequential selection. So, in all possible regression approach, what we did is that if you have a problem with k minus 1 regressors, then you consider all the 2 to the power of k minus 1 linear models, and the next step is that we fit those models and we evaluate them with respect to some criteria. So, the criteria could be the coefficient of multiple determination, which is called R square. The criteria could be MS residual, it could be adjusted coefficient of multiple determination, that I am going to talk about this one today, and also it could be the Mallows statistics, that is denoted by CP. Okay. Let me talk about the criteria for evaluating the subset regression model. One criteria is residual, mean square. So, we denote it by MS residual. Okay. So, what we observed in the last class is that SS residual P, by this one we mean that the residual sum of square for a model involving p minus 1 regressors. So, this one decreases as the number of regressors increases, but the same is not necessarily true for MS residual. So, MS residual may increase if you increase the number of regressors also. That is what we observed in the last class. Now, well, what is MS residual? MS residual is MS residual associated with the model involving p minus 1 regressors is equal to SS residual p by n minus p. And of course, lower value of MS residual p indicates better fit. Okay, so now what we will do is that we will plot MS residual, minimum MS residual against P. Okay, so the P is the number of unknown parameters in the model, and we will plot minimum MS residual along the y axis, right. So, what we do is that see, given a P, all possible models with p minus 1 regressors are evaluated and the model giving minimum MS residual P is tabulated. Okay, so to explain this one, let me recall my one example we discussed in the last class. So, we will be considering the same example, the hauled cement data. So, here we have 4 regressors and 1 response variable. So, here k is equal to k minus 1 is equal to 4, k minus 1 denotes the number of. So, here k minus 1 is equal to 4. So, k minus 1 stands for the number of regressors. Well, and then what we do is that we write down the models, all possible models. So, here this is the model I said with no regressors. So, the number of regressor variable is equal to 0 here, equal to 0 here. So, that is why P is the number of unknown. So, there is only one unknown, that is the intercept. So, P is equal to 1 for this model. Now, these are the model involving one regressor, or we will say that these are called one regressor model. That is why P equal to 2, because the number of unknowns for these models is equal to 2. These are the model with involving 2 regressors, that is why P equal to 3, and these are the model involving 3 regressors and P is equal to 4, and this is the full model involving all the 4 regressor variables, that is why P is equal to 5. And then first we write down all possible models, and then we take one model and we fit that model. Okay. that is what we did in the last class. You considered the model beta naught beta 1 x 1 plus epsilon, and you compute the SS total, SS residual, SS regression, and you write down the ANOVA table. Here is the ANOVA table for the first model, and similarly you have to do the same same job for all possible for all the 16 possible models. Well, now what is the MS residual here? The MS residual for this model is 115.1. So, that is mentioned here. The MS residual for this model is 115.06 more precisely. And similarly, you fit the second model, you get the ANOVA table, you find out the MS residual value. So, this way you compute the MS residual value for all the models involving one regressor, for all the models involving two regressor variables. These are the MS residual, and similarly for the other models also you compute the MS residual value. Now, what we do is that the minimum MS residual value in this class is 80.35. So, we tabulate this one, and the minimum in this class is 5.7. So, we will tabulate this one in our in this graph here. So, for p equal to 1, for p equal to 1, p equal to 2, 3, 4, 5. Well, for p equal to 1, that means there is no p equal to 1 means this model, no regressor. The MS residual value is 2 to 6, right. Okay, so suppose this is 10, 20, 30, and then it is maybe 200 here. So, for p equal to 1, it is 2 to 6. So, somewhere here. Now, for p equal to 1, it is 2 to 6. For p equal to 2, it is 80 point. For p equal to 2, it is 80.35. So, you plot somewhere here. I am not very particular about this scaling. Now, for p equal to 3, it is 5.7. So, somewhere here. For p equal to 4, it is the minimum one is 5.33. Okay, so, and for p equal to 5, it is 5.98. Okay, so this is 5.33 and 5.98. Okay. So, what happened here is that this value is for MS residual 3 is equal to 5.7, MS residual 4, for p equal to 4 it is 5.33, and MS residual 5, for p equal to 5 it is 5.98. So, what happens here is that initially initially MS residual decreases and then it stabilize for some time and then it may increase also. So, here it is increasing little bit from 5.33 to 5.98. So, this because for SS residual it is not true. SS residual is always a decreasing function, but that the same is not true for the SS residual, the same is not true for MS residual. So, it may increase also. Okay. So, if the newly added regression variable is not relevant to the response variable, then the reduction the reduction in SS regression is not sufficient to compensate the 1 degree of freedom loss in the denominator. That is why MS residual increases also for some time. Well, so what we do here, so we choose a value p such that MS residual p is almost equal to the MS residual for the full model. Okay. Or we choose a value of p such that value of p where MS residual p turns upward. So, here these are the selection criteria. Either you choose a p in fact it is the number of regressors in the regression model p minus 1. So, you choose a p such that the MS residual p is almost close to the MS residual for the full model. Otherwise, you choose a p such that from that point MS residual p turns upward. So, here you can see that MS residual decreases till p equal to 4 and then it turns upward, because for 5 it is again the value is more than the value for p equal to 4. So, here it turns upward. So, here you can choose p equal to 4. The meaning of this one is that so this MS residual criteria suggests that you go for the model involving the regressor x1, x2, x4. Also this other two models, like the model involving x1, x2, x3 and the model involving x1, x3 and x4, they have also the comparable value of MS residual. So, either you can go for this model or these two models, and if you prefer the model with two variables, then of course you have to go for the model which involves x1 and x2. Okay, so, this is how we evaluate the model using the MS residual criteria. Now, next we are going to talk about one more criteria that is called adjusted coefficient of multiple determination. And this one is denoted by R bar square. Well, so let me just recall R square. R square is the coefficient of multiple determination, which is equal to SS regression by SS total, and this one is equal to, if I okay, this one is equal to 1 minus SS residual by SST. Now, if I say that this R square is associated with the model which involves p minus 1 regressors, then I will put a p here, 1 p here and 1 p here. Now, what we know is that SS residual p always decreases as p increases. So, from here you can say that this implies, this statement implies that coefficient of determination R square p, this always increases as p increases. So, from here we can say that R square p or R square is not a good measure of the quality of fit. Let me explain why, because see, whether the newly inserted or newly included regressor variable is relevant to the model or not, irrespective of that fact, whatever regressor variable you include, SS residual always decreases and R square always increases with the when the number of regressor variable is number of regressor variable increases. So, that is why R square can't distinguish between whether the newly added regressor variable is relevant for the model or it is irrelevant for the model. So, that is why R square or SS residual is not a good measure to check the quality of fit. Well, so that is why what we define is that we introduce adjusted coefficient of multiple determination. So, what is that? This RP bar square, this is the adjusted coefficient of multiple determination. The only difference is that this here we replace this SS residual p by MS residual by MS residual p, and here we replace the SST by MS T, and then this can be written as, now this adjusted R square can be written in terms of R square. So, this one is equal to 1 minus, what is MS residual? When there are p minus 1 regressors in the model, I can write that as SS residual by the degree of freedom n minus p. So, this is nothing but MS residual p, right. Now, what is SST? MST is nothing but SST by the degree of freedom is n minus 1. So, this one is equal to 1 minus n minus 1 by n minus p into SS residual p by SST, and this one is nothing but 1 minus r square. So, this can be written as 1 minus n minus 1 by n minus p into 1 minus r p square. And since here we have replaced the SS residual by MS residual, as I said before that MS residual will not necessarily always decrease as p increases. So, here from there you can say that r p square, you can observe that r p bar square value will not necessarily increase with the addition of any regressor. So, that is why this adjusted coefficient of multiple determination, it is a better measure than the usual r square. Now, let me just illustrate for this model how to get this adjusted coefficient of multiple determination. We have the fitted model and ANOVA table for the first model. Well, then what is the adjusted coefficient of multiple determination for this model? Okay. So, there p equal to, for this model y equal to beta naught plus beta 1 x 1 plus epsilon. So, here number of unknowns is equal to 2. So, p equal to 2. So, basically I am computing r 2 bar square for this model, for this specific model. So, this one is equal to 1 minus n minus 1, that is 13 minus 1, 12 by n minus p, n is equal to 13 for that hulled cement data. So, n minus p is equal to 11 and 1 minus r square, r 2 square. Okay. So, what is the value of this r 2 square? The value was 53.4%. Okay. So, this one is nothing but 0.534. Okay. So, r 2 square is nothing but SS regression by SS total, which is equal to 1450 by 2715. Please refer my previous class. So, this one is equal to 0.534. So, this value is equal to 1 minus 12 by 11 1 minus 0.534, which is going to be equal to 0.492. So, this way, so this is the value of the adjusted coefficient of multiple determination for the first model is 0.49. So, here is I am writing in percent. So, it is instead of 0.492 I am writing 49.2%. Okay. So, similarly, you feed the second model, you get the you will get the value of adjusted coefficient of multiple determination. Similarly, you do for all the model here and for all the model involving 3 regressors and 4 regressors. These are the value. Well, so what we do is that we plot coefficient of adjusted coefficient of multiple determination against the value of p. Okay. So, here also you all possible models with p minus 1 regressors are evaluated and the model giving maximum RP bar square is tabulated. So, of course, higher value of adjusted coefficient of multiple determinations indicates better fit. That is why we consider the maximum value from each class R p bar square. Well, so what we know is that the maximum 1, 2, 3, 4, 5 and let me put 20, 40, 60, 80, 100, right. Let me have the values. So, R p equal to 1, when p equal to 1 the value is equal to 0. Okay. When p equal to 2 the maximum value is 64.5. Okay. When p equal to 3 the maximum value is 97.5. When p equal to 4 the maximum value is 97.6, okay, and here 97.3. So, basically we will tabulate these values. So, for 0 p equal to 1 it is 0, for p equal to 2 it is 64.5. So, somewhere here. For p equal to 3 the value is 97.5. So, it is somewhere here. For p equal to 4 the value is 97.6, it is 97.6, and for p equal to 5 it is 97.3. 3. Okay. So, here you can see it is not necessarily it is always increasing, it can this value of adjusted RP square can decrease also sometime. Well, so it suggests that the selection criteria is that you select a P where RP square reaches maximum. Okay. So, what according to this coefficient of multiple determination, among the two regressor models, this one is the best, the model involving x1 and x2, and among the 3 regressors model, both are good, see, I mean all 3 are good. Model involving x1, x2, x3, x1, x2, x4, x1, x3 and x4, they all have a very high value of adjusted coefficient of multiple determination, right. And see the difference here, it is 97.6, and for the 2 model, for the 2 regressor variable model, the value is 97.5. So, there is a little gain in terms of this adjusted coefficient of multiple determination. If you add one more variable with this, say if you add x3 with this model, then the value is getting increased by 0.1. So, before it was 97.5. Now, if you add along with x1, x2, if you add either 3 or 4, the increase is not that significant. So, I mean I personally I will go for this model, x1, the model with 2 variables x1 and x2, that is enough, because there is no significant increase in the value of the adjusted coefficient of multiple determination if you add one more regressor variable here. Next we will be talking about one more criteria, that is called Mallows statistic, and it is denoted by Cp. Okay. So, this statistic measures the overall bias or mean square error in the fitted model. So, by the mean square error is measured by this one is yi hat minus e y, this one yi hat is the ith fitted value, right, and what is e y? this is the expected response. This is the expected response for the regression, I mean for the regression model, I mean the full model, regression model. Okay. And the difference, so the difference between the fitted value and the expected value is the error. You square it, so it becomes square error, and then the mean is, you take the mean means expected value of this one. Well, and this is for the ith observation, you sum it over I equal to 1 to n, and this one is standardized by dividing it by the sigma square. Well, so this is called the mean square error, and it can be proved that that mean square error is, this quantity can be estimated by SS residual for the model involving p minus 1 regressors by MS residual, and this is for the full model, of course, okay, minus n plus 2p, and this one is denoted by CP. I am not going into the detail of this, how to get why CP is an estimate of this mean square error. Okay, that is all. Now, here we need to observe something like first one is this MS residual is computed using all the regressors in the model, and SS residual P is computed for a model with only p minus 1 regressors. So, we know about this notation. Now, what we need to observe something here, what is the value of CP for the full model. Okay. So, here is the definition, I mean here is the expression for CP. Now, well, let me write again, CP equal to SS residual when the model involving, for the model involving p minus 1 regressors, and this is MS residual for the full model minus n plus 2p, and p is the number of unknown parameters in the model. Now, when p equal to k, that means the number of regressors in the model is k minus 1. Okay. So, when if p equal to k, then of course SS residual p is SS residual for the full model, right. Then what is the value of CP when p equal to k? That means what is the value of CK? So, CK is for the full model, CK is SS residual you can write in bracket k, that means the SS residual in fact for the full model, by MS residual minus n plus 2k. Okay. So, here this is nothing but n minus k minus n plus 2k, which is equal to k. Well, so what we observed is that for p equal to k, Ck equal to k. That means, for the full model the Ck value is close to, I mean is in fact its Ck value is equal to k, and you can note that the low Cp value indicates better fit. Okay. So, our selection criteria for for the model here is that of course, a small value of Cp is desirable, and also the Cp should be close to, I mean Cp is small means it is close to p. If Cp is equal to p, that means the model involving p minus 1 regressors is almost equivalent to the full model. Okay. Let me illustrate this Mallows statistics using our example. First, okay, so for p equal to 2, I will calculate the Cp value. For p equal to 2, that means I am considering the model y equal to beta naught plus beta 1 x 1 plus epsilon, here p equal to 2. So, I will compute C2. C2 is, I said it is SS residual 2 by MS residual minus n plus 2 into p. So, 2 into 2. So, this one is nothing but 1, 2, 6, 5. This is the SS residual. This is the SS residual by MS residual. No, do not take this MS residual. This MS residual for the full model. Well, where is the full model? This one is the, here is the full model, and you take this MS residual value. Okay. So, this is the MS residual for the full model. So, you take so SS residual 2 by 5.98, which is the MS residual for the full model, minus 13 plus 4, which is equal to 202.53, right. So, this is the Cp value 202.5 is the Cp value for this model. Similarly, you get the ANOVA table for the second model and compute the Cp value. So, these are the Cp values for model involving 1 regressors and 2 regressors, and these are the Cp values for the model involving 3 regressors and 4 regressors. So, I said that the smaller value of Cp or low value of Cp indicates better fit, and also it should be close to p. So, here you can see that these three models involving x1, x2, x3, x1, x2, x4 and x1, x3, x4, they are acceptable under the CP criteria, okay, because these values are small. I mean, especially 3.02 is a small one, and low CP value indicates better fit. So, among these models, this one is the best one, but all three are acceptable because they are reasonably small and also close to P. Now, here see there is no the small CP is here 138, but of course, it is very far from 2. Okay, so, this is not acceptable according to the CP criteria. Now, for 2 variable case or model involving 2 regressors, this one is the small one 2.68, and also it is very close to 3. So, the model which involves x1 and x2 is best one in, I mean, it is a good acceptable model in terms of the CP criteria. Well, so here again you can draw the graph of you can plot CP against P. So, here is the P along the x axis, and you plot minimum CP along the y axis. So, 1, 2, 3, 4, 5, 6, and here also write 1, 2, 3, 4, 5, 6. Because I want to draw this line CP equal to P. Okay, for P equal to 1, the value is something 138. So, it will be somewhere here. For P equal to 2, sorry, for P equal to 2 it is 138, sorry, for P equal to 2 it is 138. For P equal to 1 it is for P equal to 1 it is 442, and for P equal to 2 it is 138. So, for P equal to 1 it is somewhere here, and for P equal to 3 it is 2.6. So, it is below the line 2.6 here. For P equal to 4, for P equal to 4 minimum is 3.02, and for P equal to 5 it is 5. Okay. For P equal to 4 it is 3.02, so it is somewhere here. And for P equal to 5 it is 5. So, you can see if you draw, now you join them. So, the selection criteria is that you choose a P small value of CP which is close to P are desirable. Okay. So, from this graph you can say that, I mean, for P equal to 3 the value is equal to 2.68. Well, so among the two regressor model, this one is the best in terms of the CP criteria, and among the 3 regressors models, all 3 are acceptable in terms of the CP criteria. And overall, if you see, all the there are we talked about different criteria for evaluating the model. If you combine them now, for the 2 variable model, it appears that the model involving x1 and x2 is the best one with respect to all the criteria. And for among the 3 regressor models, this one is, of course, it's good with respect to all the criteria. So this is how we write down all the models involving maximum k minus 1 regressors, and then we feed them and we evaluate them in terms of using some criteria, and we choose the best model out of the all possible models. Thank you very much.